Hello, my dear friends and viewers. You are welcome to Jonathan online class. In this video, we are going to look at this concept on the board, which is a topic in mathematics. And that concept is permutations, which is part of probability. By permutations, we mean the number of ways, different ways of arrangement of elements of a set or items in order. That is permutation. And it has a simple rule. Now, let's see the task on the board. The question asks, in how many ways can the letters of the word Jonathan be arranged in order? This is simple, but before we proceed in solving this task on the board as example for clear understanding, in permutation operation, when you have elements, maybe members of a set or elements, letter by, let's use the letter N to represent the set of elements N. Then, and you have maybe the members or items or elements of that set that are alike. We can represent it with letter A. That is N permutation A. So by formula, this is given by N factorial over A factorial. So that is the formula or the basic rule of operation of permutations. Now let us look at this. Of course, here is the number of the set, the elements of the set. Here this represents the items that are identical in the set. So with this idea, with this concept, we now go by this. But if the elements are the same, that there is no different group of items in that element, it's just the n factorial. Then in operation, you understand what we mean by this factorial operation. Now, looking at what we have on the board here, we have Jonathan. Look at the letter Jonathan. We have Jonathan. Now, from this letter Jonathan, you see we have identical elements. We have O appearing 2 times. We have letter E appearing 2 times. We have letter N appearing 2 times. These are identical elements. But first of all, how many elements of the set are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 members. So our N is equal to 9 here. N is equal to 9 members, because of the number of letters in the word Jonathan. Then we have identical. Let's assume that A is the first identical, which is 1, 2. That is O. A is for first identical. So we have 2 O's. There. Then we have what? There are 2 O's. Also, let B be the other identical. We look at this, we have identical E and the E 2 times. So we have also 2 E's. Then let's see the other identical element. We have N and N. So also 2 identicals. That is 2 N's. So look at it. So we can now say that our permutations, for the permutation now, the permutations of this word, letters of this word, the ways of the arrangement, that is the permutation, is given by N factorial over A factorial, B factorial, C factorial, which is equal to, our N is 9 times, I can just say 9, this is factorial, I can say 9 factorial over, this one A is 2 factorial, B is 2 factorial, C is 2, N is 2 here, 2 factorial. Now what I mean is A is 2 occurrence, B 2 occurrence of E, C 2 occurrence of N's. That is it. Now, which gives us 9 times 8. You multiply down successively. Times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what we mean by that factorial. This is what we mean when we say factorial. Then here, 2 times 1, 2 times 1 for this 2 factorial, times 2 times 1 for this 2 factorial, times 2 times 1 for this 2 factorial. Assuming that we have 3 factorial here, supposing that the letters E appear 3 times, the letter E appears 3 times, is that in 3 factorial, which means 3 times 2 times 1. So in that order. So depending on the number of appearance of that item, identical items, determines the factorial of that element in the operation. So we continue. This will give us, look at this now. There is 2 times 1 here, which is 2, cancelling 2 here, 2 times 1 here. Then we look at again, of course, 2 times 2 here is 4. So this 2 times 2, which is 4, cancels this 4 here. So we are left with the permutation. We are left with 9 times 8 times 7 times 6 times 5 times 3. 9 times 8 times 7 times 6 times 5 times 3. Because this is 2 times 2 is 4, 4 times 2 is 8, and 4 times 2 here is also 8. That has been what? Eliminated. So let's multiply out here, do simple operation here to multiply this out. We have 9 times 8. Of course, you should know that 8 times 9 should give you 72. That 9 times 8 is 72. So we have 72 times 7 here. We are taking it one after the other. 9 times 8 is 72, which is here, times 7 here. 7 times 2, 14, write 4, carry 1. You see how to multiply it with a calculator. Carry 1 here. 7 times 7 is 49 plus 1, 50. So we have this. Times 6. The next is 6. 6 times 4 is 24. We write 4. We take 2. Then 6 times 0 is 0. Plus that 2. 2. 6 times 5 is 30. We have this. Okay. Times what next? 5. Then 0. 0 plus 2. Write the 2. 6 times 5 is 30. We have it here. Times 5. 5 times 4 is 20. We write 0, carry 2. 5 times 2, 10 plus 2, 12. We write 2, carry 1. 5 times 0, 0. Put down that 1. 5 times 3, 15. Times 3 remaining here. 3 times 0, 0. 3 times 2, 6. 3 times 1, 3. 3 times 5, 15. Write 5, carry 1. 3 times 1, 3 plus 1, 4. That is our answer finally is 4, 5, 3, 6, 0. So this is our answer finally. Our final answer is this. 4, 5, 3, 4, 5, 3, 6, 0. Good. So I believe with this example, you'll be able to tackle similar tasks under permutations. The next time we are going to look into combinations, which is another ways of selection, order of selection. Thank you for paying attention to this class. For more of these solutions in physics and mathematics, subscribe to my YouTube channel at Jonathan Online Class. Also follow me on my Facebook page. Thank you.